I'll just write so this is a uniform circular ring, and we are finding at a point on its axis. Okay. Simple derivation. Just take a look. So suppose this is my ring. Okay. So this ring will also have some kind of a thickness usually. I mean, not that we are taking any thickness right now, but I'm just showing it as small, thin, but thin circular ring. Okay, thin circular wire, we can say. But we will use this in our future situations. Okay, so we have a thin circular ring, and due to this thin circular ring, for now I will use only one thing. Okay, so we have a thin circular ring, and due to this thin circular ring, at a distance of A on its axis, this is axis. This is my ring, and the axis is perpendicular to the plane of the ring, right? Now, let us take this radius as R.
Yes, sir.
So simply how we solve this is take a small element at this end. Let us say it has a length of dx and a charge of dq. Okay.
Yes, sir.
Now the electric field due to that small element will be in this direction.
So here, everywhere the electric field is constant.
Because
the distance is same.
Because the distance is same. But the magnitude of the electric field is constant.
Yes, sir.
Magnitude of the electric field is constant. Direction is varying.
Yes, sir.
Okay. Now what we will do is that I will take a diametrically opposite same element dx having a charge dq. Okay.
Yes, sir.
Electric field due to this fellow over here will be in this direction.
Yes,
let us say the total charge is capital Q.
Yes,
and let us say the electric field, see obviously the electric field due to this element will also be dE because distances are the same. Symmetry, yeah. Distances are the same, charge is the same, everything else is. But why am I taking a diametrically opposite thing is, now when I take components, see this angle is theta, this angle is also theta. Right?
Yes, sir.
So my horizontal components d sine theta will cancel each other.
Yes, sir.
It will make my life easy. So I'll do d sine theta, d sine theta. They will cancel each other, and I will only have 2 d cos theta.
Yes, sir.
Okay.
Yes, sir.
Now, what is d? d is equal to a dq upon distances
under root of r square plus a square.
Under root of a square plus r square. This distance is a, this distance is r.
Sir.
So I'll just draw the triangle here. A, r. This is under root of a square plus r square.
Yes, sir.
But of course, I need the square of that. A square plus r square.
Yes, sir.
Directly, I will write my E net at the point A on the axis is equal to integral of 2d cos theta.
Yes, sir.
What is cos theta? This angle is theta. So my cos theta will be adjacent by hypotenuse.
Yes, sir.
Okay. Simply this fellow will become integral of 2 K dq upon a square plus r square into cos theta is adjacent upon
under root a square.
Everything is a constant. 2, K, A, R, everything is a constant except dq.
Yes, sir.
Total charge on the wire is capital Q. So what should be my limit?
Yes, sir.
Total charge on the wire is capital Q and I am integrating with respect to dq. So what should my limits be?
It should be half of Q.
Good. 0 to Q by 2. Perfect. So simply everything else is a constant. I will have Q by 2. So first let me write everything else. 2Ka a square plus r square whole to the power 3 by 2 into capital Q by 2. Correct?
Yes, sir.
Integral dq is q and upper limit minus lower limit, it is q by 2. 2 will get cancelled. My final answer will be a capital Q a square plus r square whole to the power.
Sir, you told you were considering a thickness, small thickness, so that doesn't matter, right?
That doesn't matter because we are using thin. But the reason why I drew it 2 lines is because we are going to use such kind of a thing in future for aerial and all.
Yes, sir.
Okay, so for now we are taking it as one, but eventually when we go for aerial distribution, this is all linear distribution. When we go to aerial distribution, when we are taking a circular element, then we will take a small thickness also. I will show it to you in tomorrow's class.
Sir, when we are telling linear, it's only along length.
Along length. All linear charge distributions or linear distributions are along length. Linear charge distribution, linear mass distribution can be there in center of mass, rotation, gravitation. And in electrostatics, we have linear charge distribution. So linear distributions are all along length. That's why we are using the word linear. Surface charge distributions are all called aerial charge distributions. There we will consider areas.
Sir, but how do you know when we have to consider aerial or linear?
When should we consider area and when should we consider length and when should we consider volume? This is the problem, right?
Yes, sir.
If suppose Camlin pencil is there, it's very thin. You will treat it as a single wire or a rod.
Yes, sir.
That is linear. But if I will choose my hand, this is a thick rod. So now
Yes,
this actually has volume.
Yes,
But
sir.
suppose I have charge only on my palm area. This is aerial. Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. There is an important, we can say, let's say derivation or important question. Okay. So the electric field, obviously in the question, he's not going to tell that what is the electric field. But now we know that the electric field is kq by a square plus r square whole to the power 3 by 2, right?
Yes, sir.
He'll ask the question, find at what a will electric field be maximum. Why is because for this uniform circular wire, the electric field at the center is 0. Now, electric field at infinity is also 0.
sir.
Why will the electric field at infinity be 0?
There also components will get cancelled.
Not the component. No. If
There
you
are
have
only
a
components only.
if you have a point charge, what is the electric field due to the point charge? KQ by R square.
Okay, because it's very huge, it will be 0. Yes, sir.
When R tends to infinity, electric field due to any point charge will be 0.
Yes, sir.
So electric field due to any type of a charge at infinity has to be 0.
Yes, sir.
So electric field at the center is also 0.
Yes, sir.
Electric field at infinity is also 0. So somewhere
Yes.
in between it should be having a maximum.
Yes, sir.
Are you getting my point?
Yes, sir.
The electric field is 0. From here it is increasing. Somewhere it will have a maxima and again decrease and it will be 0 again. So
Yes,
this is a
sir.
very common question. Find the position on the axis, distance on the axis from the center where the electric field is maximum. Clear?
Yes, sir. Yes, sir.
Maxima or minima, what is the first condition in maxima minima calculus
We have
differentiation?
to check the first differential
And equate it to 0.
and equate it to 0. Again, when we do the second differential, we have to check the sign.
Right. So for maxima or minimum, first thing is that we have to do the first differential and equate it to 0, right?
Yes, sir.
So for this kind of a question, of course, he will not give you this also. This is, we are supposed to know this electric field due to a ring at a point on the axis. Okay.
Yes,
He'll only
sir.
ask find A where electric field is maximum. Automatically, my first step has to be that electric field with respect to A should be 0. Okay. Because the only variable that we are considering here is A.
Yes, sir.
Fine.
Yes, sir.
When I'm anyways differentiating and equating to 0, I'm not bothered about the constants K and Q. So my mathematical expression will eventually become differential of A by A square plus R square whole to the power 3 by 2 upon dA should be equal to 0.
Yes, sir.
We will use U by V.
Yes, sir.
So when I use U by V, what will happen?
A square plus R square whole power 3 by 2 minus
dA. And of course, it will cancel out with this.
Yes, sir.
Minus A times
Minus
differential.
okay. 3 by 2 of A square plus R square into 2A.
Whole to the power 1 by 2 into 2
into 2A
is equal to 0.
Yes, sir.
Here also I'll have dA and whole divided by dA. dA and dA will get cancelled.
Yes, sir.
We are not bothered about that. Okay?
Yes, sir.
So I will rewrite this fellow. So I have A square plus R square whole to the power 3 by 2 is equal to, I'll take this entire term over there. Okay?
Yes, sir.
A times 3 by 2 A square plus R square whole to the power 1 by 2 into 2A.
Yes, sir.
1 by 2 will get cancelled. Here I'll have only 1. 3 by 2 minus 1 by 2 is 1.
Yes, sir.
So my next thing will become A square plus R square is equal to 2A into A.
Instead of 0, we could write d by d.
Instead of?
Sir, instead of 0, you could write d by dA and simplify on the left hand side.
So why am I equating to 0 is what you're asking?
No, sir.
Then?
No, nothing. I got it.
Okay.
Yes, sir.
We just applied u by v, v du
Yes, sir.
minus
That
u
is
dv.
yes, sir.
And in denominator also we will get v square, which we did not substitute because anyways everything is
Because
0.
zero. Yeah.
So only numerator is what is important for us. dA will also get cancelled everywhere. So I just took this term to the right hand side.
Yes, sir.
And square root of a square plus r square, if you cancel with this, this will become whole to the power 1.
Yes, sir.
2 and 2 will get cancelled. Here I'll have 3a square.
Yes, sir.
So simply a square and 3a square will become 2a square over here. Yeah.
Yes, sir.
So r square is equal to 2a square. Therefore, I can write a is equal to plus or minus r by root 2.
Yes, sir.
Is this clear?
Yes, sir.
I have a doubt. Can I write plus or minus over here?
If we remove it depends on the length. No.
I am asking, can I write plus or minus? R by root 2 is anyways mathematics.
Yes, sir.
Can I write plus or minus? What does plus or minus mean? It means above r by root 2 or below r by root 2, both points I will have a maximum.
Yes, sir, you can.
Are you getting my point?
Because it can be symmetric over there.
Are you getting my point?
Yes, sir.
So ultimately, understand this. Okay. If I am drawing electric field with respect to A, E with respect to A, what is A? A is the distance from the center, and I'm taking upward as positive.
Sir, but now whatever we got, we have to check it with double differential, so we'll know which one is exact.
So double differential we do to find out if it's a maxima or a minima, right?
Yes, sir.
Correct. So let me first explain this and then we'll see if it's a maxima or a minimum.
Yes, sir.
So what I'm trying to say is that I am drawing electric field with respect to A. And let us take A also as a vector. Okay. A is distance along the positive y-axis. Okay. Or along the vertical line in the upward direction. Upward direction I'm taking as positive.
Yes, sir.
What did we say at the center? When A is 0, electric field is 0.
Yes, sir.
When A is infinity, electric field is 0.
Yes, sir.
So my graph simply looks like A is 0, electric field is 0. A is infinity, electric field is 0. So my graph basically looks like this. Are you getting my point?
Yes, sir.
And if you go below, that is negative A, there also you will get one maxima at minus r by root 2. See, this length is r by root 2. Are you getting my point?
Yes, sir.
This length is r by root 2. There I have a maxima. On the negative axis also, will I have a graph or not?
Yes, sir.
So basically, should I go up or should I go down?
Will be down.
Because
it's negative.
Negative. Because electric field is a vector. Right? So basically, same graph over here, I will go something like this and come.
Sir, how do you know it is rising a little bit?
Rising.
Because there's a maxima in between that.
Right. How do you know? No. First you understand your own question. How do you know it's rising? Rising from where?
I mean, there's a loop.
How do you know it is going up and going down?
Yes, sir.
So you know electric field is in the upward direction. 2d cos theta.
Yes, sir.
Upward is positive vector.
Yes, sir.
So I have to go upward only as I'm moving in the positive x direction, positive a direction. I'll have to go up only,
Yes, sir.
then come down.
Yes, sir.
Why am I coming down? Because electric field again at infinity will be
Zero.
0. So from 0 to 0, from 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. That's how I'll go, right?
Yes, sir.
So I'll reach one point where I'll have to stop and come back.
Yes, sir.
And because electric field is a vector here also, I'll go to one point, I'll stop and come back.
Yes, sir.
Now by looking at this graph, you already know this is the maxima and this is the minima if we take it vectorially. The magnitude of the electric field will be maximum. Magnitude of the vector will be maximum at both the points.
Yes, sir.
Minus r by 2, r by root 2 and plus r by root 2. But the vector wise, you will have a maxima here and a minima over here.
Yes, sir.
So at what a value will I have maxima? I'll just write it as r by root 2. And this is an objective question. Is it clear?
Yes, sir. Yes, sir.
Xerox. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.